Hello everyone. The title of this video is Add and Subtract Rational Expressions, or fractions, whose denominators are opposites. Alright. So in this video, I'm going to be going over 8 examples in which we're given two fractions to either add or subtract, and in each example, the denominator of one fraction will be the opposite of the denominator of the other fraction. Right? And by opposite, I mean, times -1. Right? That's what it means to have the opposite of something, is that thing times -1. Okay. So all the examples I'm going to be doing in this video are taken directly from a free online textbook at openstacks.org. This book is in their Intermediate Algebra 2nd edition, and I'm in section 7.2, titled Add and Subtract Rational Expressions. I'm working on exercises 91 through 98. Alright, so that's 8 examples under the heading Add and Subtract Rational Expressions whose denominators are opposites. Example 1 in the video will correspond to number 91. Example 2 will be number 92, all the way down to example 8 will be number 98. And I will have timestamps for each of these examples in the description of the video. So if you'd like to see any particular one, like say you just wanted to look at me doing number 96, that would be example 6. Right? So you would go to click on the example 6 timestamp. Right? And I like to try to remember to say this too in every video. While I'm working in my video here, when I bring up a new example, pause the video and try to work the example out yourself before you watch me do it. Because if you're just watching me do something and not working on it yourself, you're not going to learn anything. So pause it, try to work it out yourself, then watch me do it, and compare your work with mine, and see where you made mistakes or where you could improve or whatever, and compare and contrast our work and see how well you're grasping the material. Okay. So example 1. Alright, this is exercise 91 in that section 7.2. So notice here I've got two fractions, and we're asked to add or subtract, and then I added this. I said and simplify. Now I'm going to assume that you know how to simplify a fraction. Right? You factor the numerator, factor the denominator completely, and then cancel any common factors. Right? So I'm assuming a lot here that you know how to factor polynomials. Right? And if you don't, and if you're unfamiliar with factoring polynomials, I would suggest you refresh your memory. A good place to do that would be in Chapter 6 of the OpenStax Intermediate Algebra 2nd edition text. All sections of Chapter 6 are about some method of factoring polynomials. So get into that. And also, if you want, I put up previous videos on factoring and also simplifying fractions from section 7.1 of the same text. Alright, so each fraction here, you got, first one is the numerator is 10 times v divided by, and the denominator is 2v minus 1 plus, right, we're adding, and then this other fraction has a numerator of 2v plus 4 divided by, and then their denominator is 1 minus 2v. So right now, the denominators are not the same, right? These are not common denominators, or not the same denominator. And that's not good, right? When you add or subtract fractions, in order to be able to add, the denominators need to be the same. Okay. And that's only for addition and subtraction. I hope you understand that, right? When you multiply or divide fractions, you don't need the denominators to be the same. Right? It's just when adding and subtracting. Well, right now they're not the same, but one thing maybe you notice as well, this denominator has two terms, positive 2v and negative 1. And this denominator also has two terms, but there's negative 2v and positive 1. So basically they're the same two terms with opposite signs, right? Positive 2v, negative 2v, negative 1, positive 1. If that's the case, if every term has just the opposite sign, that means that they are opposites, right? Let me just show you here. I'll write the first fraction again, 10v over 2v minus 1 plus, and the second fraction, the numerator is 2v plus 4. The denominator is simply negative 1 multiplied by, or just a minus sign if you want, right? Negative 1 or just a minus sign. It's the opposite of. And if I factor negative 1 out of this expression in the denominator of the second fraction, I'll have positive 2v minus 1. So do you see now, right, hopefully you can see now that the denominators, right, denominators are opposites. And that's going to be the case for every single example in this video. The denominators will be opposites. So one denominator will just be negative 1 multiplied by the other denominator. So this denominator is negative 1 times the first one, as you saw here. All right, so a very quick way to ensure that we get a common denominator, right? Opposite denominators are not the same. Well, a very quick way to make them the same is to get rid of the negative 1. Now there are multiple ways you can do this. All right. One way to do it is to take one of the fractions and I multiply the numerator by negative 1, right, the whole numerator. Right, so I'm multiplying 2v plus 4, that whole thing, by negative 1, and multiplying the denominator by negative 1 as well, right? You can't just multiply the numerator of a fraction by a number and not the denominator, because that'll change the value entirely. You must multiply both the numerator and denominator by the same number in order to make it like you're multiplying by positive 1, right? Negative 1 divided by negative 1 is positive 1. So that won't change the value of the fraction. And let me see what we get now. Right? So now, I haven't touched this first fraction yet. Still have 10v over 2v minus 1 plus, and still got the plus, and then I multiplied the 2v plus 4 by negative 1. That's both terms, right? You're not just multiplying 2v by negative 1, but the whole numerator by negative 1. So that'll be minus 2v minus 4 now in the numerator of the second fraction. And then down in the denominator, right, the whole reason I multiplied by negative 1 over negative 1 is so that the negative 1's in the denominator make positive 1. And then I can say that they're gone, right? There's no reason to write a factor of positive 1. So negative 1 times negative 1 is positive 1, and I'm left with now 2v minus 1. So that's a very quick way to take opposite denominators and make them the same denominator. Right? Now I have what I want when I'm adding or subtracting. Now we have common denominators, right? The denominators are now the same. And this is what I'm going to be doing every single example. Taking one fraction and multiplying the numerator and denominator by negative 1 and then adding or subtracting those fractions, right, once the denominators are the same. Now, once the denominators are the same, right, both of them are 2v minus 1, I'm hoping that you recall, how to add and subtract fractions. Right, now that the denominators are the same, I can add. Right, and once you have a common denominator, when you add them, that will be the denominator of the sum or the difference. Right, when you're adding or subtracting, that common denominator stays throughout. It's the numerators that get combined. So I'm taking 10v, the first numerator, plus, and then the second numerator, negative 2v minus 4. And usually when something has more than one term, I'll put parentheses around it. But with addition, you don't need to, because it's like multiplying by positive 1. But then I combine like terms. 10v plus negative 2v would be 8v. And then you have the plus negative 4, that's minus 4 here. And so the numerator is 8v minus 4. The denominator is still this common denominator, the one we got them to be the same, this 2v minus 1. And there we go. All right, this fraction right here is the sum of the two that we started with. But I'm not done yet. Okay. Again, you may recall that after addition or subtraction, so after adding or subtracting, simplify if you can, right? If possible. Now, hopefully, again, you remember how to simplify fractions. So you factor the numerator completely, factor the denominator completely, and then cancel any common factors that the numerator and denominator may have. All right, so I'll pull this to a separate sheet here. Okay, so 8v minus 4. That can factor further, right? There are two terms with a common factor of 4. So I can pull 4 out, and then you could write 4 as, factor that further to 2 times 2 or 2 squared if you wish, but I'm going to leave it as 4 for now. And then if I pull a 4 out, I'll have 2v minus 1 left over. And so the two factors of the numerator are 4 and 2v minus 1. And the denominator is just 2v minus 1. And that doesn't factor any further. So it's its own factor, and hopefully you can see the common factor in the numerator and denominator. That would be the factor 2v minus 1. So I divide those, and when you cancel common factors, technically they both become the number 1, right? Anything divided by itself is 1. So all I'm left with now is 4 in the numerator, 1 in the denominator. So this is 4. So this fraction plus this fraction will be equal to 4 all the time, no matter what you plug in for v, except one value. So usually I do this earlier, but I'm going to do this with every example here. If the expression has variables, I would like to point out the values that the variable can't be. All right. Now remember, the values that make your expression undefined are any values that make a denominator equal 0 throughout the problem. Because if a denominator is 0, right, that means you're dividing by 0, and that's undefined. That's no good. So 2v minus 1, that's the factor I'm seeing in all these denominators. So that can't be 0. 2v minus 1 can't be 0, meaning that v cannot be a half. Right? Because if v were a half, You'd have divided by 0 here, you'd have divided by 0 here, here, and if you see a denominator that will be 0 anywhere throughout the problem, you can't use that value. Right? So v can't be a half. But any other value of v is fine to use. So if I replace v with anything but a half, the sum of these two fractions will be equal to 4 all the time. And let's test that out. Now I'm only going to do this for this first example. All right, but if you want to test this, see if this is actually happening, let's take the original expression, right, and then the value of the final expression and see if they're the same for any choice of v. Right, again, as long as v is not a half. Now the final expression always has a value of 4. Right? So how about if v were, again, anything but a half? How about if v were 0? Well, go back to the original expression. 10 times 0 is 0, divided by 0 minus 1 is negative 1. 0 divided by negative 1 is 0. So I have 0 plus, and then 4 divided by 1 is 4. 0 plus 4 is 4. I get 4 for the original, 4 for the final. That works. And it should work out like that no matter what you plug in for v. How about if v were 1? As long as v is not a half, because I never want to divide by 0. But if v were equal to 1, you'd have 10 times 1 is 10. 2 times 1 minus 1 would be 1. So the first fraction would have a value of 10. The second fraction would have a value of negative 6. 10 plus negative 6 is 4. And I get a value of 4 again. All right. And you could do this all day long. Replace v with any number you want, except a half. And the value of the original expression should be equal to 4. Right, the value of the final expression. And again, I leave it to you to test other values. All right. So moving along here, let's go to example 2. Same thing. Very similar setup. You have two fractions being added, and you may notice that the denominators are not the same. 5w minus 2, and this denominator is 2 minus 5w. But they're opposites, right? 5w here, negative 5w there. Negative 2 here, positive 2 there. Opposites. Every term is the opposite. So again, very easy to fix. So I take one of the fractions. It really doesn't matter which. I prefer having the lead coefficient be positive, so I'm going to keep the 5w minus 2, and I'm going to transform this other denominator. So we're going to take this fraction, right, the denominator and the numerator, and multiply by negative 1. So I multiply by negative 1 in the denominator. I also multiply by negative 1 in the numerator. And don't forget that we're distributing here. Right? There are multiple terms. We're multiplying the entire numerator, the entire denominator, by negative 1. And after doing this, right, since the denominators were opposites, after this multiplication by negative 1, the denominators will be the same. So the first fraction I didn't touch, right, so it's still 20w divided by 5w minus 2, plus, then this fraction I multiplied the numerator and denominator by negative 1. The numerator will have terms of negative 5w minus 6, and then the denominator will have positive 5w minus 2. And now I have the common denominator I want. Right, you need the same denominators to be able to add or subtract. Alright, well now I'm adding. And that common denominator, that same denominator, will stay the denominator in the sum. So I get 5w minus 2 there. And then I add these numerators again, just combining like terms. 20w plus negative 5w would be 15w. and then, I have 0 for the constant term here, plus -6 would be -6. Wonderful. Now, this is all well and good. This is the sum of these two fractions. It's just not simplified, right? We can factor this further. The numerator, 15w and -6, have a common factor of 3. If I pull out a 3, what will be left will be 5w minus 2. And the denominator is also just 5w minus 2, and that doesn't factor any further. It's its own factor. And I'm seeing this common factor of 5w minus 2 in the numerator and denominator. So I'm left with the value of 3 over 1, or just 3. So that first fraction, right, without the negative ones, right, the original statement, the original sum will always be 3 for whatever I plug in for w, as long as w is not 2/5. And I'll write that at the end here. All right, w can't be 2/5, because if w were 2/5, you'd have denominators of 0 throughout the problem, and you can't have a denominator of 0. Right? You can't divide by 0. That is undefined. But everything else is fine. Right? I'm not seeing any other denominator factors with w in it, so the only w I can't use is 2/5. All right, and I leave it to you. Test this out. Take the original expression, again without the negative ones here, take the way it originally looked, replace w with any number you want except 2/5, and see that the value of the original sum is 3 all the time. Okay? And it should be, if I did everything correctly. All right. Next example. Again, I'm doing the same stuff for every single one of these, because for every single one of these, the denominators are opposites. All right, so same deal. This denominator, 8x minus 3, the denominator of the other fraction is negative 8x plus 3. See, 8x, negative 8x, opposites. Negative 3, positive 3, opposites. So these are opposites. So once again, I'm going to take the second fraction, multiply the denominator by -1, and also multiply the numerator by -1. And notice the parentheses I'm putting around these, because we're multiplying the entire numerator by -1, not just the first term. So it'll involve distributing every single term, and the same thing with the denominator, multiplying by -1. And since these denominators are opposites, multiplying one of them by -1 will make them the same. So now I have this, 10x squared plus 16x minus 7 over 8x minus 3 plus, and then this numerator now is negative 2x squared minus 3x plus 1 over, and the denominator is 8x minus 3. Right, they are now the same, since they were opposites originally. And now that they are fractions with the same denominator, I can now add them and make a single fraction with that denominator, right? The common denominator continues on and is the denominator of the sum. Right? So I have 8x minus 3 in the denominator, and then I'm just combining like terms in the numerator. Take the left terms plus the right terms. 10x squared plus negative 2x squared would be 8x squared. 16x plus negative 3x would be positive 13x. Negative 7 plus 1 would be negative 6. Right. Okay. Then I'm probably going to be able to simplify this. All right, let's see if now the numerator is a quadratic. 8 times negative 6, doing the AC method here, is negative 48. And factors of negative 48 that add up to 13 are positive 16 and negative 3. Yeah, so I would need to factor that. And then you can do the grouping thing, but I'm just going to jump to the end And I'm assuming you know how to factor. So it'll be 8x minus 3 plus 2. And that'll give me the positive 16x and the minus 3x for the positive 13x. Right? And divided by 8x minus 3. All right, and you're seeing hopefully a common factor now in the numerator and denominator. Numerator has a factor of 8x minus 3. The denominator also has a factor of 8x minus 3. So those will become 1. And I'm left finally with this x plus 2 in the numerator. So just x plus 2. All right. So again, the original sum without the negative 1's, right? The way it originally looked, I could replace x with anything except 3/8. And at the end here, I'm writing x cannot be equal to 3/8. Because if x were 3/8, you'd have denominators of 0 throughout this problem. And that's not good. But if you were to replace x with any number besides 3/8, the sum of the first two fractions, the original, will be equal to whatever x plus 2 is. Alright, so if I replaced x with 0, the original expression and this would both have a value of 2. If I replaced x with 1, the original expression and this final expression would both have a value of 3, and so on. And I leave it to you to test some values, make sure that that's working out. Okay. All right. So now, from here on out, I'm just going to say I'm multiplying the numerator and denominator by -1 without actually writing it, just to keep the original expression the way it looks. So again, number 4, we have two fractions with denominators that are opposites, 3y minus 7 and negative 3y plus 7, right? Or 7 minus 3y. So once again, I'm going to multiply the numerator and denominator of the second fraction by -1. All right, so I'll even, right here, I'll just multiply numerator and denominator. I'm only writing it one more time here. I'm multiplying the numerator and denominator of the second fraction by -1. That will transform the denominator of the second fraction to be the same as the denominator of the first fraction. So the first fraction I didn't change, right? 6y squared plus 2y minus 11 divided by 3y minus 7. And then plus, right, still plus here, and then I multiplied the numerator by -1, so that's negative 3y squared plus 3y minus 17. Right? You're doing every single term by -1. And then the denominator is also multiplied by -1, making it 3y minus 7. Now the denominators are the same, so I can add the fractions. This common denominator stays the denominator throughout. Alright, so 3y minus 7. And then I'm adding these terms from the first numerator to the terms from the second numerator. 6y squared plus negative 3y squared would be 3y squared. 2y plus 3y would be positive 5y. Negative 11 plus negative 17 would be negative 28. Right. And then I factor the numerator, factor the denominator, and cancel any common factors. The numerator will factor to 3y minus 7 times y plus 4, right? Because that'll give me 12y minus 7y for the positive 5y. Divided by, and then 3y minus 7 is the only factor of the denominator. And I'm seeing the common factor of 3y minus 7. Right? 3y minus 7 in the numerator and the denominator, leaving me with y plus 4 left over. And once again, at the end, I'll state any values that y cannot be replaced with. So going through this, right, there's denominators of 3y minus 7 showing up, 7 minus 3y, whatever, this is the opposite. That can't be 0. So when is 3y minus 7 or 7 minus 3y? When's that equal to 0? When y is 7/3. Right? So y cannot be 7/3. It can be any other number but 7/3. And I leave it to you to check. Go back to the original statement, replace y with any number you want except 7/3, because that'll make me divide by 0, and see if this sum is equal to the value of y plus 4, right, the final expression. So when I replace y with 0, the final expression and the initial expression should have a value of 4. If I replace y with 1, the final expression and initial expression should have a value of 5, and so on, right? And I leave it to you to test those, test some values. Alright, so all those were addition. Alright, those first 4 examples had addition involved. These next 4 have subtraction, but it's the same procedure. Alright, it's the same procedure. So look, this first fraction, z squared plus 6z divided by, and then the denominator is z squared minus 25. Then you have minus, and then this fraction, where the numerator is 3z plus 20, denominator is 25 minus z squared. Opposites. The denominators are opposites, right? You got z squared here, negative z squared there. Negative 25 here, positive 25 there. Every term in this denominator is the opposite of the terms in that denominator. All right. So once again, I'm going to multiply the numerator and denominator of the second fraction by negative 1. So I'll have z squared plus 6z over z squared minus 25 minus, and then I'm multiplying the numerator of this second fraction by negative 1, so I'll have negative 3z minus 20. That's the new numerator. And I'm also multiplying the denominator by negative 1, giving me positive z squared minus 25. And now hopefully you see the denominators are the same, z squared minus 25. And now that the denominators are common, the denominators are the same, I can put them together and we can subtract. Now remember, with subtraction, got to be a little careful, especially when that second numerator has more than one term like this one does. The denominator is still z squared minus 25, right? That common denominator stays as the denominator of the difference. And then I'm taking the first numerator, right, z squared plus 6z, and subtracting the second numerator, the entire second numerator, negative 3z minus 20. All right, you're not just subtracting negative 3z, you're subtracting the entire second numerator. So that will involve distributing a negative. Right? You're subtracting all the terms of that next numerator. So let's see what we get. So in the numerator, now we have of the difference, we have z squared. Then you have 6z plus 3z, right? Minus negative 3z. 6z plus 3z would be plus 9z. And then we have minus negative 20, which would be plus 20. So there's the simplified numerator, right, after subtraction. And then the denominator is still, z squared minus 25. So great, there's the difference of those two fractions right there. And that's perfectly fine. It's just not simplified yet, though, right? We should be able to factor the numerator. Hopefully we'll be able to factor the numerator and denominator and cancel any common factors. Okay, so z squared plus 9z plus 20. That factors to z plus 5 times z plus 4. The denominator, z squared minus 25, that's the difference of squares. That'll factor to z minus 5 times z plus 5. And hopefully you're seeing the common factors in the numerator and denominator, right? They both have this common factor of z plus 5. So the expression I end up with is z plus 4 in the numerator over, and then z minus 5 is left in the denominator. And there you go. That's the simplified difference of these two fractions right here. Now, got to be careful though, right? You can't just plug in anything for z. All right. Look throughout the problem. You know, the denominators are z squared minus 25 and 25 minus z squared, and z minus 5, z plus 5. Well, z minus 5 is in the denominator, so z can't be 5. And z plus 5 was also in the denominator right before I canceled, so z can't be negative 5 either. So z cannot be 5 or negative 5, because if z were 5 or negative 5, you'd have denominators of 0 throughout this problem. And you can't have a denominator of 0, right? Can't divide by 0, that's undefined. But for anything else, right, replace z with any other number, and the value of the first difference, the original expression, will be the same as the value of this expression here. So for example, if I replaced z with 6, both expressions would have a value of 10. Right. If I replace z with negative 4, both expressions would have a value of 0, and so on, as long as you're not replacing z with 5 or negative 5. And I leave it to you to check other values of z. Alright, number 6. Same kind of problem. Alright, every single example. So I'm going to leave, again, the first fraction the same. We have a squared plus 3a divided by a squared minus 9. And minus, and then the second fraction, notice the denominator of this fraction is the opposite of the denominator of the first fraction. All right, you got a squared, negative a squared, negative 9, positive 9, right? Every term in this second denominator is just the opposite of the terms of the first denominator. So since they're opposites, it's very easy to make them the same, right? It's very easy to get a common denominator here. Just multiply the second fraction, multiply the numerator and denominator by negative 1. And I'll just do this here. I'll go times negative 1, right, in both the numerator and denominator of the second fraction. Now in doing so, the terms of the numerator become negative 3a and positive 27, right, multiplying the numerator by negative 1. And then the denominator becomes a squared minus 9. Right, and now I have what I want. I have common denominator. Putting those together then, right, you keep that common denominator, right, a squared minus 9, still the denominator. And then I'm taking the first numerator minus the second numerator, right? Don't forget, you're subtracting everything from the second numerator, both terms, not just the negative 3a. So we have a squared minus, there's no a squared there, so there's just a squared. We have 3a in the first numerator minus negative 3a. So 3a minus negative 3a, that's 3a plus 3a, would be positive 6a. And then 0 minus 27 would be minus 27. And so the simplified numerator after doing all this subtraction, a squared plus 6a minus 27. And that is the difference in these two fractions. Great. It's just not simplified. Right? We gotta factor. Factor the numerator, factor the denominator, and cancel any common factors. A squared plus 6a minus 27 factors to a plus 9 times a minus 3. And a squared minus 9 factors to a minus 3 times a plus 3. And then I see the common factors of a minus 3 in the numerator and denominator. I'll cancel those. Those will become 1. And I'm left with, the expression a plus 9 in the numerator and the factor of a plus 3 in the denominator. So this is our final expression here, a plus 9 divided by a plus 3. Now be careful, right? Like every example so far, I also would like to point out the values that I can't replace a with. So looking throughout the entire problem, I'm noticing, there's a minus 3, a plus 3 in the denominator here. That's a squared minus 9. So a can't be 3 or negative 3. All right? A can't be 3, a can't be negative 3. Because if a were 3 or negative 3, you'd have denominators of 0 throughout this problem, and that can't happen. But for anything else, you're fine. Replace a, and I'll leave it to you. Test out some values of a. If I replaced a with 0, this expression and this expression would both have a value of 3. If I replaced a with 1, this expression in the original and this expression would both have a value of 10/4 or 5/2, 2.5, and so on. Right? And again, I leave it to you. I leave you to test different values of a, as long as they're not 3 or negative 3, right? Because you get undefined expressions that way. All right, and the final two examples are very similar. Right? All these problems are the same, pretty much, where you're subtracting two fractions with opposite denominators. So I'm just going to keep, like I've been doing with all these, I'll keep the first first fraction the same, 2b squared plus 30b minus 13 over b squared minus 49 minus, and then I'm going to multiply the numerator and denominator of the second fraction by negative 1. So I'll put a little times negative 1 to the numerator and denominator of the second fraction. So the numerator becomes, negative 2b squared plus 5b plus 8. And the denominator becomes, b squared minus 49. Because you take these were opposites, so if you multiply one of them by negative 1, they'll be the same. So now they're the same denominator, which is what you want when you're adding or subtracting. And adding or subtracting expressions with the same denominator, the resulting difference has that same denominator. So the denominator is still b squared minus 49. And you're taking the first numerator minus the second numerator. So you're not just subtracting the first term, but all the terms of that second numerator. So what we have here is 2b squared minus negative 2b squared. Minus negative 2b squared is plus 2b squared. So we have 2b squared plus 2b squared, that'd be 4b squared. And we have 30b minus 5b. That'd be plus 25b. And we have negative 13 minus 8 be negative 21. And great, there's our simplified numerator and denominator, but the whole fraction isn't simplified. Right? We have to factor the numerator and factor the denominator. Alright, so the numerator is another quadratic here. 4 times negative 21 is negative 84. And I would need, let's see, not 1 and 84, not 2 and 42. 3 and 28. Yeah, so positive 28 and negative 3. Alright, so I need to do this. So again, you should know how to factor. I'm not going to go into all the details. Right? So I'd have 4bb and then plus 7 over here, minus 3 here. Right? That'll give me the plus 28b minus 3b for the plus 25b. Great. And then the denominator, would factor to b minus 7 times b plus 7. And hopefully you're seeing the common factor of b plus 7. They both have a common factor of b plus 7. Those cancel. And the final expression I'm left with is, numerator 4b minus 3, denominator b minus 7. Now, as with all the other examples, I'm going to list over here the values I can't replace b with. And it looks like 7 and negative 7, right? There were factors of b minus 7 and b plus 7 in the denominators. That was b squared minus 49. So b cannot be 7 or negative 7. But you can replace b with any other number. 0, 1, 2, 3, 4, 5, whatever you want, half. And the value of the original difference should be the exact same value as this final expression. All right, and like so, for example, if I were to replace b with 8, both expressions, the original and this final one, would have a value of 29. And you can plug in, all sorts of different values. If I plugged in 6 for b, all right, which is allowed, it's not 7 or negative 7. This would be, 24 minus 3 is 21 divided by negative 1. That'd be negative 21 for both values. Both expressions would have a value of negative 21. And you should test that. Plug in different values of b here and test that the original and final have the same value. All right, one last example, example 8. Very, very, very similar to all the other ones where the denominators are opposites. C squared minus 16, 16 minus c squared. Same terms, just opposite signs. So in order to get the denominators to be the same, right, I'll leave one of them alone. Right, so again, like all the other examples, I'm going to leave the first fraction alone. So I have c squared minus 16 in the denominator. Then we have minus. And for the second fraction, I'm going to multiply the numerator and denominator by negative 1. And that, because they're opposites, that will make this denominator the same as the other one, c squared minus 16. And the numerator now will have negative c squared plus 8c plus 10. Right, so now I have two fractions with the same denominator, and we're subtracting. That common denominator will stay the denominator in the difference, so c squared minus 16 again in the denominator here. And don't forget, you're taking the first numerator minus the second numerator. You're subtracting every single term of that second numerator from the first numerator. So not just the first one. So it's like distributing a negative, like I've done in the previous several examples. So we have c squared minus negative c squared. That'd be c squared plus c squared, which is 2c squared. Then we have 5c minus 8c. That'd be negative 3c. Then we have negative 10 minus 10. That'd be negative 20. All right. Okay, so great. This fraction is the difference in these two fractions. Totally fine. It's just now we got to simplify, right? Factor the numerator, factor the denominator, and cancel any common factors. Numerator factors pretty easily. You'd have to have 2c in one of the factors, c in the other. And I would need 8 and negative 5. So negative 5 here, positive 4 there. And that gives me the 8c and the minus 5c for the, oops, the other way around, sorry about that. Minus 4 here, plus 5 there. I apologize. So this would factor to 2c plus 5 times c minus 4, right? That way I get minus 8c plus 5c for the minus 3c, and then you get the minus 20. All right, so that's 2c plus 5 times c minus 4. And then the denominator factors to c minus 4 times c plus 4. And then I cancel common factors, right? The only one I'm seeing, again, is there's c minus 4 and c minus 4, right, in the numerator and denominator. So those become 1. And all I'm left with now is the factor of 2c plus 5 in the numerator. And since it's its own factor, don't need parentheses around it. And the only factor down here is c plus 4. So again, since it's the only one, I don't need parentheses around it. And there you go, 2c plus 5 divided by c plus 4. Now, just as with all the other examples, off to the side, I will list all the values that c cannot be replaced with. And that would be 4 or negative 4. All right, because if I see c minus 4, c plus 4 in the denominators, right, c squared minus 16. If c were 4 or negative 4, you'd have denominators of 0 throughout this problem, and that's bad, right? You can't divide by 0. It's undefined. But for any other value of c, replace c with anything else, and the value of the first expression should be the same as the value of the last expression. All right. So check it out, right? If I were to replace c with 0, the first, replace z with 0 in the original, replace c with 0 here, and both of them should end up with a value of 5/4. All right, replace c with 1 in the original and the final, and both of them should end up with a value of 7/5. And again, I leave it to you to plug in different values of c to test it out and make sure your final expression is always equal, always the same value as the original. All right, again, just so long as c is not 4 or -4. Great. So hopefully watching me go through these 8 examples, where the denominators were opposites. And very simple, just if you recognize that the denominators of two fractions are opposites and you're adding or subtracting them, you want them to have the same denominator, just multiply one of the fractions by -1 over -1. And then you go from there. Pretty simple. Alright, hopefully watching me go through these helps you out when you're working on similar problems, and thank you very much for watching.